So we've already taken a look at vertical and horizontal asymptotes. Today we're going to be taking a look at the oblique asymptotes. Now the oblique asymptotes, this basically says we're going to just look at where the oblique asymptote is a line. Okay, so it's going to have the form y equals mx plus b, as most of our lines do. And we'll see why, right? It's the same thing with the asymptote being from, at the extremes, it's going to go closer and closer to the line, all right? And basically that's all that this is saying here. So we've got a diagram here of where the function in blue is getting closer and closer to the oblique asymptote in red when x gets either very, very large or very, very small, okay? So we have this situation when we have a rational function, and it's when the numerator, the degree of the numerator, is just one more than the degree of the denominator. We are not going to handle any cases where the degree of the numerator is 2 or more than that of the denominator. Okay, so when the degree of the numerator is 1 more than the degree of the denominator, we will end up with an oblique asymptote, all right, and not a horizontal asymptote. You're either going to have one or the other. Okay, so in this situation, we take a look and our function follows that rule. Okay, the degree in the numerator is 2, the degree in the denominator is 1. So how do we find out what that equation actually is? Well, we actually divide the polynomial out. So we have our numerator as x plus 1 is being divided into the numerator, the 2x squared plus 3x minus 1. When you take a look and go through all of these, you're going to end up with some real values, okay? Remember how you do this. You say, okay, well, how many times does x go into the 2x squared? Well, that would be 2x times, right? Multiply the 2x by the 1, you get the 2x, subtract that line down, and you end up with 3x minus the 2x, you get an x. Bring the negative 1 down. How many times does the x go into the x? Plus 1 time. You put that on top. Then you multiply out. Okay, 1 times x plus 1 is x plus 1. Subtract that, you end up with the x minus 2. Okay, or sorry, just the minus 2. So what happens with that minus 2 is you've got that whole value, f of x turns into 2x plus 1 with that remainder of negative 2 there. Well, the negative 2 is still divided by the x plus 1. So you have that, you add that at the end, all right? So you end up, the f of x is 2x plus 1 minus 2 over x plus 1. And what we realize is that as x gets closer and closer to the positive and negative infinity, that extra piece, okay, of the function becomes closer and closer to 0. So that means that the function gets closer and closer to just 2x plus 1. Okay, so that's why that is the oblique asymptote. All right, and you have in the example, this is what it would be. So what we need to do is we need to figure out, okay, is the function itself, is it going to be greater than the line, like above the line, or below the line? Where is it approaching that from? Okay, and we will get into that as we get through the rest of this. Right now, all we're doing is we're taking a look at how to come up with the oblique asymptote, and then we'll get into, as we go through the following examples, how do we get into the, does the graph get closer from the top of the oblique asymptote, or does it get from the bottom of the oblique asymptote? We'll take a look at that at the other two videos.